I would think that most people, I would think it would be smaller. Okay, but obviously it will be bigger, because if you have more structure and you want to exploit it, then the fact that the word is occurring in the document is not enough. You have to say under what element is it occurring. So what's interesting, because of your interest in exploiting the structure, the inverted index has become larger now. So as an example, suppose I have an XML file like this, I would now need to index all subtrees in essence. Because a path query might be relevant to any one of those subtrees. So I was happily going to be indexing book, title, author, Microsoft, Bill and Gates, and I was done before. Now I have to index this, etc. So if I give you this problem as that page 2 problem in the midterm, for try a little inverted index for me, you would have needed more space. You see what I'm saying? It's sort of, to me it's counterintuitive, but it's not counterintuitive for you, good for you. You know, if you have more structure, to exploit more structure, you need a bigger inverted index. And then you will obviously be able to, support pathways. And then there are other issues too, such as can you change the way, matching between subtrees. Now, basically you're going to be comparing subtrees. Query is a subtree and the result is a subtree. So in some sense, before you were comparing two bags. Query is a bag and result is a bag. And bag similarity would have been enough. Now you want to compare two subtrees, where the elements of subtrees might themselves be bags. Okay, so you need metrics for tree similarity, subtree similarity. Okay, this is one example. I'm not even going to go into it. I'm basically trying to tell you that now you need support for deciding whether two subtrees are similar or not. Okay, those are the complications that you will have to deal with because you have structure. So structure makes querying easier for the user. The querying easier in the sense that you can get results that you really wanted. Okay, but the background now, you need to have a bigger, inverted index. You need to have a more sophisticated similarity measurement. Okay, this stuff is actually directly taken from the textbook on IR that I have a link to, so you can read more if you want on that. I'm not going to go more into detail. Okay, the next thing I want to do before we end today is XML viewed from a database side. So we sort of viewed XML from a IR side and looked at what changes, what kinds of things will change. Okay, so if you look at it from a database side, what kinds of things will change? Okay, so when I say what kind of things will change here, I was saying what kinds of changes will happen from the traditional IR techniques. The reason you are interested in this is traditional IR would have just indexed this separately, whereas now the IR engine has to index all the subtrees. That was interesting. Okay, and similarly when I talk about databases, my interest is how does it change from traditional databases. Here I have to assume that you have some clue about traditional databases. If not, this part of the next 5 minutes would not make sense to you. But that's okay, it's only 5 minutes. Okay. So the thing about databases, the reason database people were excited about it is essentially, previously there wasn't any on-the-wire transfer language for data. If you have a tuple, then if I'm just sending, Sam B, Rao C, you don't know what is Rao and what is C. Okay? If I put XML, then basically it provides a way of saying, okay, name begin Sam, grade begin B, name begin Rao, grade begin C. And so the other guy essentially is getting schema information along with the tuple. Previously, the way you would be able to, transfer a data from one place to another is to first send the schema information and say, keep looking for this schema as I keep sending you raw tuples. And I'll say, I'm now sending you a tuple from table T5 and look up your schema and figure out what the columns are, and then I'm going to only send you the raw values. Whereas here, XML essentially is going to put much more verbose language where it's putting tag information in front of every value. It's self-describing, okay? It's probably the least exciting part, from a conceptual point of view. How hard is it to just put a tag, begin, tag, end? what's interesting is there was no motivation for database people to agree upon any standard. And so they weren't agreeing upon. There were probably motivations, but they weren't agreeing upon. And then XML came along and they say, hey, this looks like a good place to use, good thing to use. Okay, so that's one thing that currently is done. All data when it's transferred in the XML format, unless there are two programs written, kind of centrally, so that both of them know what to do for the first value, second value, third value. Okay. So one interesting thing is that there is no, as I said, there is no standard syntax for relational data. XML is expressive enough that it can represent relational data, and it also can represent non-relational data. For example, data where you have arbitrary number of authors. That's not a single table, because you don't know how many columns are there in a table. How can you have a table without knowing how many columns are there? And yet you can write it next. Okay. So one of the interesting things is that databases can be, although it's become less so now, but in the heyday of databases, there used to be tons of different types of databases: relational databases, deductive databases, object-oriented databases, and they all are storing data, and they should be exchanging data. And when they exchange data, object-oriented database, what is it going to exchange with the relational database? Now you can say, I'll write whatever I have into an XML form, and you can do whatever you want with it. It's not particularly earth-shaking, but that's a big deal. Okay. And then also you can, the other thing of course is, so even if you don't want to change even if you don't want to change anything about the way you handle the data, you may want to still know XML, because you want to convert whatever you have said into XML. So for example, you don't know what language I'm thinking as I'm speaking. I might be thinking in some other language than English. But as long as I make it up as something that sounds like English, you are happy. Right? So they say that on the internet, nobody needs to know that you're a dog. So on internet, nobody needs to know that you're a relational database. As long as all databases exchange information in XML, you don't know what database you're using. Okay? And of course, the other thing is that you can now, so the other thing is that now that I start talking in English, so suppose I only know, when I first started speaking in English, I would actually generate sentences in my mother tongue, Telugu, and then convert it into English. Okay? And then because I say something in English, then they'll ask me a question back in English. Right? And then I will slowly translate it back into Telugu, and I'll form my Telugu answer, convert it to English. By this time, people have left. Right? I still remember there was this one time when a couple of people said hi to me, and then I translated it into Telugu, didn't quite know what to say, and converted it back into English and said something, they were lost. They're gone already. The point is, the moment I start sending stuff out in XML, you think you can ask me queries in XML. Okay? So, if a database is providing an XML front end, then it should be ready to answer queries on the XML data. Saying, oh, I'm a relational database, I don't really understand these kind of XML queries, is like me saying, I'm just converting stuff into English through some, output device, and I have no input device which converts your English questions into what I understand. That's not going to be good. Right? So they will also have to sort of support XML queries. Again, remember that I can take the XML query, convert it into, SQL query, answer it on my database in SQL database, RDBMS, get tuples, quickly tag them, present it as XML. Okay, many databases get to do this, and in fact, there is a whole area. There were lots of techniques for doing this efficiently, and there are interesting theoretical questions which we'll talk about next class because we run out of time, as to whether if there is an XML query, does it correspond to an exact SQL query, a unique SQL query. If you ask me something in English, can I translate it to a unique query in Telugu? Okay, you don't know anything about Telugu probably, but if an Eskimo asks you a question about, so if you go to an Eskimo and ask him a question about snow, what kind of a snow are you having these days? And this guy is thinking, where do I start? I have 32 different words for describing snow. And you're just talking about snow, like the cold stuff or non-cold stuff, And so basically, the one question you have corresponds to multiple possible translations in this other language. So is this true for an XML query translated to relational database? Secondly, one of completeness. Can every query in SQL every query in XML be translatable into an SQL query? Sometimes that's not possible. One of the interesting things that happens is, since I am giving you this data, okay, you can actually now ask me, give me a tuple which has 2 grades. Or give me a tuple which has no value for the grade. These are not standard database queries. Standard database queries are all about values, not about whether attributes are present 5 times or 3 times. But since I put this out in front of you, you can ask questions on the tags. So you can have meta queries, which are queries on the tags themselves, and then you should be able to handle them. These are the kinds of complications that database people get into because they made the mistake of acting like they are XML databases. Just as, if I act like I understand English and start talking in English, you will ask me questions in English. And if I can't translate it into a language I can understand, I'm stuck. Okay? We'll talk about these, and the first thing we'll do in next class when we come back is, one thing that XML doesn't have, databases have, is a schema. Whenever you give a database, you have a schema. So you need first a description of schema for an XML file, which is not required for a file to be XML. But for it to be usable by a database, it needs to have a schema. So we'll talk about DTDs and XML schema languages, and then from there we'll go on to this.